Alex. And can we just get one more round of applause for Alex? Very excited. This is the first Elm Spring ever. I mean, we're all at the inception of a new conference. Always a very exciting time. So, yeah, quick show of hands. How many people recognize this screenshot? Okay, cool. How many people are familiar with the Gilded Rose in terms of like the programming thing? Okay, cool. So actually, pretty similar numbers. So where this talk comes from is basically a question I've seen asked pretty often is, with all these types, like, when should I write tests in Elm? Like, should I write tests in Elm? I'm kind of biased as the maintainer of Elm test, I think yes. But you know, in general, there is this kind of question of like, when? When does it make sense to reach for one versus the other, or can they work hand in hand? So the general, like, sort of pithy answer that I tend to give is like test logic. When you have something that's like business logic and all the types check out, it's still possible that it's doing the wrong thing. And maybe a more specific, slightly more helpful version of that is like test conditionals. Now, that's like not an exhaustive list of things to test. But if you think about it, anytime you have a conditional, by definition, every branch in the conditional has to have compatible types. So you kind of can't get help from types because the whole point is the compiler is just checking that they're the same. But of course, they're branches, so they're going to do different things. So anytime you have conditionals, there's a possibility that that's a good case for a test. But let's think about this question a little bit deeper and say, okay, when can types and tests go hand in hand? And I think to do that, we need kind of a bigger example. I can't think of a really concise, minimal example without some sort of motivation of a bigger problem. And that's where the Gilded Rose comes in. So for those who are not familiar with the programming problem, this is a code kata. I'm not sure exactly what a kata is, but it's something that Terry Hughes created, and it's essentially sort of a programming exercise. You can find the code for this, the original code, at notmyself/GildedRose on GitHub. And essentially, the premise behind the problem is that we work for this store, which I guess it's a reference to World of Warcraft where it's an inn, but in our case, it's a store called the Gilded Rose that sells sort of an eclectic bunch of items. And we're coming into this existing code base where people have coded up the rules for how all these items work and how they sort of like degrade over time. And we're going to come in and add a new feature to this code base. But as you'll see, while we're doing that, we're going to kind of want to make the code base a little bit better because the person who wrote the existing code did not do the best job. And as we're going to see, it's going to be important to use both types and tests to do, I think, the best job with this. So in this example of the type of business logic we're dealing with, let's say you're a store and you sell bananas. You put the bananas on the shelf, and a day goes by, they don't sell. Another day goes by, they don't sell. Over time, the bananas get sort of worse in quality. They get degraded. They eventually become moldy bananas, and then, over time, they maybe disintegrate. I originally had an image of a moldy banana here, but I decided that, you know what, everyone's going to have a better time if I just have a black and white banana instead. Point is, over time, quality decreases. And eventually it gets all the way down to 0. It's like no one will possibly buy this because we just have like banana ashes on the shelf. So this is sort of like one of the basic rules of the Gilded Rose is that we have inventory and it goes bad. Okay, so that's rule number 1. Each item has a quality value between 0 and 50. So 0 meaning unsellable, 50 meaning it's awesome, people will be excited to buy it. And at the end of each day, the system decreases each item's quality by 1, so decrements it. This is sort of the baseline rule. And then once the item reaches its sell-by date, quality decreases by 2 per day instead. So it's like really going downhill fast, and it's going to get down to 0 sooner than before its sell-by date. These 3 rules are the basic rules of the system. Okay, but this wouldn't be a terribly interesting problem if we just had these basic rules. So of course, as with any production system, there are edge cases. So there's 3 of these as well. First one, there's one item called Sulfuras, Hand of Ragnaros. And it's not a banana, but it is instead a legendary item, which means it has no sell-by date, it's always awesome, and it never decreases in quality, it just stays exactly as good forever. So we're going to have to hard code this sort of exception to the previous rules that we just talked about. Second edge case, aged brie, which is a type of cheese, actually increases in quality each day because it's aging more and more instead of decreasing. So it's actually approaching the maximum of 50 rather than decreasing towards 0. Another edge case. And one more edge case, backstage passes to a particular concert also increase in quality, and they increase even faster as the concert approaches because they get more and more valuable, more and more people are interested in like getting them at the last minute. And then after the concert, they immediately plummet to 0 quality because nobody really wants backstage passes to a concert that already happened. So these are our 3 edge cases. Sulfuras is legendary, aged brie increases in quality, backstage passes have a kind of somewhat complicated algorithm that we'll get into later, but they increase in quality much like brie, and then they drop to 0 after the concert. Okay, 3 edge cases. And finally, we have the new rule that we're going to implement. This is the thing that we're coming into this existing code base, which already implements, in not the most ideal way, those business rules. And this is the thing that we're going to add. We're going to introduce the concept of the conjured items. Like some sorcerer has conjured this item and it sort of fades out of reality over time. Unclear on the ethics of selling this thing, but whatever. They degrade in quality twice as fast as normal items. That's the thing that we need to program. Twice as fast as normal items. Okay, so those are the rules. All right, so this is the original C# implementation. They start with a public class called item. I don't actually know C#, but I was able to look at this code and kind of figure out, okay, it's got a name, which is a string, sell in, which is like a number of days that we have left to sell it. That's sort of the sell by date. And quality, which is also an integer. This is the basic data structure that they implement all these in. Here's an example of how they initialize these things. In this code base, everything is hard-coded into the code base, not stored in a separate database. Again, questionable design decision, but here we are. So this is how everything's represented. It's just hard-coded, initialized values right there in the code. So we can see, for example, up here we have the +5 dexterity vest. This is a normal item. Age debris was one of our exceptions. That was one of our edge cases, so it's actually going to increase in quality over time. Elixir the Mongoose, another normal one, despite the name. Sounds pretty interesting, but it's normal. Sulfurus, that was our legendary one, which never decreases in quality, has no sell-by date. They represented this by sell-in equaling 0, which kind of suggests that, oh, it needs to be sold immediately. We're on its sell-by date, but actually it's not true. It's more that it doesn't have one. We'll get into that a little bit more later. Backstage passes of the concert, which again have edge case. And then finally, conjured mana cake, which initially does not have any special rules, but it's our job to introduce a new special rule for that makes it decrease in quality twice as fast. So everything in this existing code base in the C# version is dealt with using this update quality giant function. And it's just a for loop over all the items, and then inside that for loop are 16 different if statements. That's where all the logic is. That's not how I would have done it, but that's how the person who initially wrote this code did it. So it's a lot of stuff like this. So if name is not equal to age debris and name is not equal to backstage passes, and if quality is greater than 0, didn't decide to use and there, whatever, decided to do one more if, I don't know, okay, fine. Also, if the name is not equal to sulfurus, again, what are booleans? Then finally, we're going to decrement the quality by 1. So this is the type of stuff that we're dealing with. This is actually only these are 3 of the 16 ifs, but there's a whole bunch more like this. This is the existing code base that we're coming in and trying to modify. Okay, so to sum up, this is the public API in C# terms, so later on we're going to translate this to Elm terms. But conceptually what they've got here is items. When you want to create an item, you specify the name as a string, the sell-in value, which is an int, the number of days that you have to sell it in, and the quality as an int, and then the one public API that you have to update all of these is this update quality function that just takes all of them and updates all of them. So this is the public API, and when we're making the Elm translation of this, we're going to have basically the same kind of public API for it. Okay, so let's make a plan of action. Remember, our goal is we're going to try and come in and add this new piece of functionality, this conjured business logic. Implicit in that is that we're going to also try not to break the stuff that's already there. So what we're going to first do is write some regression tests, because really, if we want to make sure that we're making changes without breaking stuff, we kind of want to be able to check, somehow, did we break this thing or not? And since we don't really have any types to help us out with these 16 if conditionals, we're going to want some tests that'll help us out to answer that question, is it still working or not? Second, we're going to make some new data structures. These are going to be under the hood, behind the scenes, like not visible to the public API. The public API is going to look the same. And then finally, we're going to make sure that we maintain API compatibility the whole time. So at the end of the day, like maybe once this new feature is in, we can sit down and have some long conversations about the API. But for now, the goal is to add this one new feature without breaking stuff and only using new data structures internally. That's our plan of action. All right, step 1, write regression tests. Okay, there's one really important thing here, which I tried to emphasize subtly on this slide, which is if you're writing regression tests for an existing code base, you really want to test the public API. As in, like, don't go in and test internal implementation details, because the whole point is we want to go change the internal implementation. We're not happy with it. So by writing tests against the public API, that means that, okay, granted, it's going to be more work to set up. Like, we're going to have to write some convenience helper functions that will make it a little bit more ergonomic to test the internals, the items within this public API. But importantly, our tests will now survive the implementation changes that we're about to make. So this is really critical because we want to be able to run the regression tests and say, okay, we now have some degree of confidence that what the existing code is doing works the way we expect. And then after we make the internal changes, we want to make sure, okay, does it still work that way? And if we aren't testing the public API, those tests are going to break and we're not going to be able to use them to check after. Okay, so here's an example of the type of helper function we might want to need. So remember, public API is just one giant update everything function, right? Update quality takes a list of items and returns the new list of items which have all had their quality values updated. So let's write a little helper function inside our test module that lets us focus on one individual item. And it's going to look something like this. It takes an item and returns an item, and all it does is it says, okay, I'm going to wrap that item up in a list, because that's what update quality expects. I'm going to call it, and then just call list.head, because again, we expect that it's just going to have one element inside of it. And because it's a maybe, we're going to need to handle the default somehow and just return the item. We could make this a little bit more robust if we wanted to, and make like, okay, we want to check, are we actually getting back one item afterwards? Because it's theoretically possible that update quality, although it's supposed to update quality, actually goes through and adds items to the list. That would be bad, but we aren't checking for that in this little helper function. But that's something we possibly could do. Okay, so what do we want to verify in these regression tests? Well, essentially we want to verify the business logic, like the rules that we set out of the gilded rows. So for example, quality values always need to be between 0 and 50. They can never be below 0, they can never be higher than 50. Second, sulfurous, the legendary item, never decreases in quality. Third, normal items do decrease in quality at a rate of 1 per day. And third, like aged breed, backstage passes, increase in quality according to various rules. So these are the types of things we want to do. We want to write tests for each of these different conditions to make sure that when we call that function, all of these things are always true after we get the return value back from the test, or from the function. Okay, so that's plan one, write regression tests. We're not going to get into like what all those regression tests will look like, but strategically, that's what we want to get out of our regression tests. So let's talk about making some new data structures internally. This is the thing we're going to spend the bulk of the time talking about. So this phrase, make data structures, is also the title of a talk that I gave, and it basically talks about, this is the one piece of advice that I wish I could have given my past self if I were to go back in time when I was beginning at Elm. Just basically focusing on data structures as a way of writing code. A talk that I reference a lot is The Life of a File by Evan Shiplicki, which I think talks about really like the best place to get started when you're making data structures or you're making a new file in Elm, which is basically build a module around a type. So that's what we're going to do. We're going to start with the item type, and we're going to build a module around it. And at the end of the day, we're going to be keeping in mind that public API that we need to end up with, but for now I'm just going to start from scratch and build our way up to that. And then at the end we'll check to make sure that we actually did end up with the same public API that we had before. Okay, so I like starting with these little like header comments saying like, hey, here's where our types are going to go. And then maybe later on we'll have some other headers like that. I kind of like to think of them as like markdown headers, like an H1. And so we're just going to expose the item type. We're not going to expose its variance. So item is a custom type, which has only one variant inside of it. This is a pattern known as opaque types. Well, it can have multiple variants, but opaque in the sense that other modules cannot access its variance. They can see, yeah, there's a thing called item that exists, but they can't actually look inside of it or modify it. Inside that, I'm going to have a record, for now, holding name, which is a string, quality, which is an int, and selin, which is an int. So this is essentially copying the C# API, except I'm using sort of Elm idioms to express it. But as we'll see, we can do a little bit better over time. Okay, so first business logic rule we have is sulfurous is legendary, so it has no sell-by date. Or rather, this is the first edge case that we have. That's sort of an exception to these rules. Now, one way we could deal with this is we could do what the C# API did, which is to say, set it to 0 and just ignore it. Another thing we could do is we could put some conditionals around this and say like, oh, if we're sulfurous, do something different. But I like to think in terms of data structures first. So the first question I'm always asking myself is, okay, what are the implications of this rule on my data structures? Well, one is, hey, sulfurous doesn't have this. It doesn't have a sell-by date. It's right there in the rule. And yet here it is. It's entirely possible for us to have a sulfurous item that has a sell-by date, even though we're not supposed to. So what is that going to mean? It's pretty unclear. So what I'd rather do is I'd just rather make it like not representable. I'd rather make it so that if we have a sulfurous thing, we just do not have a sell-by date, and otherwise we do. So here's how we can do that. I'll make a new type called rule, and it's essentially saying, okay, if we're a normal item, the rule is we do have a sell-by date. If it's a backstage pass, yeah, then we also do. If we're aged breed, then yes. And for sulfurous, we do not. We just don't have that. So by capturing this in a type, I'm going to get some compiler assistance and sort of remembering this. I'm not going to have to remember, okay, wait, is it sulfurous? And that means I'm supposed to ignore the sell-by date. No, it's just captured right there in the type. And anytime I'm dealing with any of these rules, I now no longer have to remember that myself. The compiler will remind me. So in order to get a benefit from that, I need to basically get rid of selin as something that's top level in this record and replace it with this rule. So now sell-in is something that's, that information is captured inside the rule, and we have also encoded in the type that it's different for sulfurous versus everybody else. Okay, but now we have a little bit of a duplication issue here, which is that we have name, which is a string, and we have rule, which also is kind of tied to the name. So for example, would it be a good idea if I were able to instantiate one of these? The name is the string aged brie, and the rule is sulfurous. That is some legendary cheese right there, at least internally. But externally, as far as anyone can tell, when they're reading it on the screen, it's like, oh yeah, this is aged brie. Because remember, that rule thing is completely internal to this module. We're not exposing it. Nobody's going to see that that rule thing exists. That's something we're trying to use to help ourselves. But here we have basically a bug in the making. Okay, so it's better to have, I would claim, a single source of truth for what the thing's name is. So what I want to do is I want to get rid of the name string and move that into rule as well. And basically say, okay, rule is all you need to figure out what the thing's name is. And now we can sort of unambiguously specify this. I'm just going to say, yeah, this is sulfurous, and that means I can, from that information alone, figure out what its name ought to be. In other words, I'm going to write a function called name, which is going to take an item and then produce the string for that thing's name. So, for example, in the case of sulfurous, we'll say case rule of, and if it's sulfurous, return sulfurous, so sulfurous, sulfurous, Versace, Versace. And in the case of, for example, backstage pass, it'd be the same thing. But look at this normal case here. That doesn't quite look right. I mean, if it's a normal rule, we're just going to say that name is normal. That doesn't sit well with me, because if we thought back to the C# example, we had things like +5 dexterity vest and elixir of the mongoose, and both of those followed the normal rules, but they had different names. So it kind of seems like the data structure we've made here is not sufficient to capture this use case of having different normal items that have different names. Sulfurous only has one name, it's legendary. That's not true of dexterity vest or elixir of the mongoose. So basically what we need to do is we need to capture that information only for the normal case. Like we don't want to change backstage pass, aged brie, or sulfurous, or else we'll reintroduce this sort of conflicting source of truth. What we want to do is we want to just add a new string to the normal case for the name. And now in our implementation, we're good. We just have the name string that's captured in there, and when we're asking the item for its name, we can just return that in the normal case. So now we no longer ever report that a name is, quote, normal, but in the case of sulfurous, aged brie, etc., we still have a single source of truth for what the name ought to be. We can no longer have the bug where we have aged brie that is presenting itself as sulfurous. Okay, cool. So this is our current public API for the item type. We have a module, it only exposes the type item. We've just added a new thing to the public API, which is going to be this name function. So this is the only way to get its name. Internally, yeah, we have it represented in various ways, but as far as anyone outside this module is concerned, this is the only way to get the thing's name. So it sort of enforces that we're following those rules that we just set up. We're probably also going to want to add some really simple quality function, because every item does have a quality value. Ultimately, this whole software is responsible for dealing with the quality, and of course we're going to want to be able to report that at some point. So a really straightforward implementation of that would be like, okay, give me an item, I will return the quality as an int, and just essentially unwrapping it from the custom type and saying, all right, great, just give me item.quality and I will return it. That's the most straightforward implementation we can do of quality. We're probably also going to want end day, which is going to be like, okay, it's the end of the day, we need to update everybody's quality. And that's going to take an item and return a new item based on having applied all these business logic rules to update the quality. So this is almost everything that we need for our public API for item. We're almost back to where we started. But we are going to need some way to actually instantiate these things, right? All those rows that we saw where it's like, make a new one, make a new one, make a new one. Well, in C# that used the new keyword because that's object-oriented, but in Elm the way that we do this is typically we have a module that does not expose the type's internals, that is, it's an opaque type, that we need to expose some way to go from something that's not an item to actually an item in order to create one. So we'll make a function called init, and we have this open question of like, what should the arguments to init be? Well, I'm going to claim that if we want to maintain API compatibility with the C# version, this is what it's got to be. It's got to be, we take a name, which is a string, a sell-in, which is an int, and a quality, which is also an int. Because that was basically the API we had to work with. Those were the ingredients that went into making an item, and we want to preserve that so that we don't, so that our regression tests still work. Okay, so this is based on backwards compatibility. Maybe in the future we will want to change this, but for now, for the purpose of this talk, we're going to emphasize this. So here's a potential implementation for init. It's basically like, okay, we got this config record, and we're going to make a new item. We'll come back to what the rule's going to be, and then quality is essentially going to be just pass it right through whatever quality value we got. Okay, now we have to do a little bit of translation. Because internally, we're storing these things as a rule, which follows certain guarantees, like sulfurous is legendary and doesn't store a cell-in value. But init is not giving us a rule. It's giving us a name string and a cell-in int. And so we need to take those two ingredients and turn them into a rule somehow. So basically, we want to write a helper function, something that takes a config like this and turns it into a rule. So we will start with doing a case expression on it. Say like, okay, if the name is sulfurous, then return sulfurous, Versace, Versace. If it's aged brie, then we're going to return aged brie, and we're actually going to make use of the cell-in value because unlike sulfurous, aged brie actually does have a cell-in value. Note, by the way, that this means we are ignoring this argument silently. It's sort of like, instead of swallowing an error, we're sort of swallowing an argument. We're just throwing it in the trash. This is an example of where I might like to argue for changing the public API. We can't because of backwards compatibility, but if we're going to have a sit-down discussion about this, I might say, look, I'm passing in the cell-in value and it's getting completely ignored. Ideally, we would change the API such that you can't pass it in. Like you get a compiler error, you at least get some feedback, some information that, hey, this value doesn't have any meaning. There's no point in specifying it. And if you're trying to specify it, there's a good chance something is going wrong. But again, for now, backwards compatibility, we'll leave it alone. Okay, backstage pass works basically the same way as aged brie. Give me the string and I'll translate it into the internal rule. And finally, we have a default case here, which is to say, if the name is not one of these explicit 3 edge cases that we're dealing with, then we're going to take the name that was passed in and use that to construct a normal value. Because remember, normal items can have different names. All right, so this is our rule from config implementation. Great, now we can call that, and now we actually have an internal rule. So we've got an init function that takes this config that's API compatible with what we were doing before, but it actually constructs an item internally, and that's what we end up with. Great. Okay, what about this rule though? Each item has a quality value between 0 and 50. Are we maintaining this right now? Kind of aren't. Like we're really just saying like whatever config value you set for quality, we're just blindly recording that. We're not trying to enforce this at all. Okay, well let's enforce it. How can we go about doing that? Well, the most straightforward way is essentially to use the min and max functions to sort of bound it. This code looks a little weird because it says min 50, max 0, which when you say it out loud, it's like you're saying the minimum is 50 and the maximum is 0. It sounds totally backwards. It's actually the right way to do it because the min function actually says I'm going to give you the minimum of these two values. So you're saying like, oh, okay, so it's if anything, if you give me something over 50, then 50 will become the minimum and that will sort of bound it. So although it looks weird, it is actually correct. This is an example of the type of code where I look at it and it's sort of like not obviously correct, but it actually turns out to be. So even though it's quite short, it's still a little bit confusing, a little bit surprising that it works. Okay, but this will work. Now we have quality. When you call init, we're going to end up with an item that has actually enforced the quality value being between 0 and 50. Great. What about this function though? Like that's also part of our public API, the EndA function that says like, okay, at the end of the day, we're going to go and update everyone's quality value based on things degrading or maybe increasing over time. Does that enforce this? Well, no, because we haven't written it yet. But even if we had written it, do we have any like guarantee that it's going to be enforcing that function? Well, not really. I mean, unless EndA happens to call init at the end of the day. But is EndA kind of like the author of that? Are they going to remember to call init? Probably not. Probably they're just going to say, well, hey, we're inside this module. We actually get to mess with these internals. We're probably just going to update the quality and then call it a day. Well, how can we handle that? Well, one way we can handle it is we could say, okay, well, we'll just port this code, like move that into a helper function and make sure that EndA calls it. We'll just remember that everywhere in EndA, we call that, or maybe at the end of EndA before we return it, we call it. Okay, but maybe somebody new to the team doesn't necessarily realize that, and maybe they don't realize they're supposed to do that. And okay, we can like write tests, but are the tests going to catch new code that hasn't been written yet? No. Okay. And also, like, how about the public-facing function called quality that like takes item and returns an int? Maybe that's the answer. Maybe what we can do is we're going to say, okay, we'll enforce it in there. Like, we'll move it. We won't store it in here. We'll store config.quality. But every time you ask what the quality is, that's when we bound it between 0 and 50. So as far as anybody outside this module is concerned, this is the only way they can ask what the quality is. So if we put it in there, then hey, every time they ask for it, we're like, cool, we'll just at the last minute bound it between 0 and 50, and then we're good. Unless we have some code inside this module that does like arithmetic based on the quality and like maybe relies on it actually being correct between 0 and 50. It's like, oh man. Okay. How can we get it? Like really in an ideal world, we want this to just be true. Like the quality value is between 0 and 50 everywhere. Like we don't have to think about it. We don't have to be like, did you remember it? Did you remember it? Do you have a test for that? Do we have a test for that? Do we have a test for that? You wrote some new code. Did you add a test for that? Like, it's paranoid. I would much rather be like, this statement is just true. Each item has a quality value and it's between 0 and 50. Okay, what if we just like make a concept of a quality value? So we make a new module that's separate from this module called item.quality, and it exposes a quality type, which is also going to be opaque, from int and to int. So we have type quality, which internally is just storing an int. It's just a wrapper around an int, but publicly, nobody knows that. We have from int, which says, give me an int, and I'll return a quality value to you. And this is where we're going to do the bounding between 50 and 0. And then we have to int, which says, okay, I'll just tell you what's inside me. Okay, so here, we actually have, it is a true statement that values of type quality are guaranteed to be between 0 and 50. That's what this module does. That's the whole thing. It fits on a slide, but it is doing that. It is enforcing that guarantee. Cool. So here's a question. Do we test this module? Like, should we bother? I mean, this is so simple. It fits on the slide, right? Well, here's the thing, though. Like, this is where we're doing that confusing thing. Like, that if you look at it, it looks wrong. If I came across this code, I would kind of want to be like, is that right? And I can see myself like going and asking someone, is it right? Honestly, even like when I wrote it, I was like, I kind of want to try it. Because I'm like, I know what those functions do, but feels weird. So yeah, let's test it. Testing's not that much trouble, right? We can write a fuzz test. Quality is never below 0. And all it does is it says, okay, fuzzing an integer, which means we're going to get randomly generated integers. It's just going to keep calling this function like 100 times, passing a different integer each time. We're going to call quality.fromInt, passing the number, so now we have a quality value. Turn it back into an int, and say, hey, that int should be at least 0, right? It should never be below 0. No matter what possible numbers we pass into this thing, once we spit it back out, it should be always above 0. And then do the corresponding thing for above 50, right? It's at most 50, and we're done. Just 2 tests. And now we're like, cool. We're really, really confident now that actually this is what quality does, and like, yeah, we can replace this min 50 max 0 thing with quality.fromInt config.quality, and we're like, okay, that's going to work for init, and it's going to work for EndA as well. Like, this is now our internal data structure inside the item. It's really true that every item has a quality value between 0 and 50, and it's true forever. Like, any implementation anyone does inside this module, outside that module, does not matter. Like, you can't forget to mess it up, and you don't need to write separate tests for each of those cases. We've just tested the quality type itself, and we're good. We just get that everywhere. And we can keep this API the same. The public quality function that says, give me an item, I'll give you an int, it's like, yeah, sure. We just call quality.toInt on the internal one. As far as anyone outside this module knows, it's like, oh, they don't care how we're enforcing this. They're just like, yeah, just make it work, you know? Have the same API and have it work. It's like, cool, no problem. We just did that. So now it actually is a true statement. Each item has a quality value between 0 and 50, by definition. So this is a really good example of using types and tests hand in hand. Like, we were able to use our tests to confirm that quality works the way that it does, and by wrapping that up in an opaque type and using that as our internal representation, even without changing our public API, we were actually able to guarantee that no matter who joins our team, and no matter whether or not we remember to do these things, it's actually going to enforce this business logic rule. Cool. Okay, which brings us to the sort of pièce de résistance of the actual implementation, the EndA function. This takes an item and returns an item. This is where we had those 16 conditionals before. It's going to be a little shorter this time. Okay, so first of all, the basic thing that EndA is going to do is we are still going to have some conditionals. So that's going to be computing our sort of like new quality value. In terms of internal to this function, I kind of want to work in ints. I don't want to work with the actual quality type, because this is where we're actually doing the arithmetic. Like, we're going to increment and decrement the quality values. So at the end of the day, we're going to return a wrapped up item where we've changed the quality to be quality.fromInt on this new quality value. So the whole purpose of this function is really to compute this new quality thing. And we're also going to want old quality in terms of int, because that's going to be handy. So for the rest of this, we're just going to focus on what goes in here. The actual conditionals that make use of old quality and use them to figure out what the new quality ought to be, and then the rest of the function is just wrapping it back up. All right, so how do we make new quality? Okay, so as a recap, each item has a quality value between 0 and 50. Check! We actually don't have to do anything in here to do that. We've already taken care of that with our quality module. At the end of each day, which is where we are now, the system decreases each item's quality by 1, and after its sell-by date, quality decreases by 2 per day instead. All right, so this is the beginning of our conditional. So again, we're going to start with a case on item.rule, because each of these items plays by different rules, and we've now written down what all of the different rules are, all of the edge cases. We've captured that way in advance of when we actually wrote our first conditional here for this business logic of updating the quality. So if it's a normal thing, that's when that rule we just talked about applies. So in other words, if days is less than 0, in other words, it's past its sell-by date, old quality goes down by 2, and otherwise it goes down by 1. That is to say, new quality becomes old quality minus 2 or minus 1. So this one at the bottom here is representing at the end of each day, decreases each item's quality by 1, and then up here it's like after the sell-by date, quality decreases by 2 per day instead. So putting these two together, we're done with the normal case. That's it. We've implemented all the rules for the normal case, and we know that quality is already enforced. Okay, so to recap the edge cases, first one, sulfurous is legendary, so it has no sell-by date and never decreases in quality. So to implement that, we're just going to say, okay, well, just return the old quality. Never decreases in quality. Great, we're done. That was easy. Okay. Age 3 actually increases in quality instead of decreasing. Okay, so old quality plus 1 instead of minus 1, and no further conditionals needed. We're pretty far away from 16 ifs at this point. However, we do still have a few having to do with backstage passes, which are a little bit complicated. So they also increase in quality like Brie, and increase even faster as the concert approaches, according to some rules we'll see on the next slide, and then after the concert, they drop down to 0. So here's what that looks like. This is really the most complicated conditional we have in the entire program, which is just the rule for backstage passes. Now again, this is the type of thing, I would want to test this. Like I would want to write a test for this logic, but I would want to write it in terms of the public API. I want to make sure that when I run the test against this thing, that it's going to be verified that this code still works the same way as the original horrendously complicated 16 ifs version of the code. Okay. And finally, we come to the new change. This is the thing that we're actually introducing to the API. Conjured items degrade in quality twice as fast as normal items. And this is the cool part, because now that we've represented our system with API compatibility with the old system, we've implemented all the logic, we've got some new tests. Now implementing this new thing, we're going to get a bunch of help from the compiler. So here's what we're going to do. First, we're like, okay, we have a new rule. Great, let's literally add a new rule. We're going to add a new variant to the type called rule. And it's going to be conjured, so much like normal items, we can have multiple conjured item names, at least according to the way that the rule's written. And they do have a sell-by date, so we're just going to capture all of that right there in the type. And now that we've added this, we all know what happens when we add a new variant to a custom type. Elm compiler is like, cool, you have missing patterns in all of those cases we just wrote on the previous slides. So our new quality value that we were just dealing with a second ago, it's like, hey, missing patterns. We don't have something in there. So like, cool, let's add one for conjured. Great. If it's basically the same rules as normal, except it decreases by 4 after the sell-by date and 2 otherwise. Cool, done. What about our rule from config? This is the thing that says like when you call init, you're giving it a string for the name, and then we use that to construct a rule. Cool. Right now we only have one called conjured mana cake, but if we wanted to support others, we could do like string.startswith instead of doing an actual pattern match on this. But the point is that, we're all set up for that. This is enough to handle the exact use case that we have right now, or the exact data that we have right now, and it's a pretty small refactor to make it more flexible if we want to. Okay, then again, we have the name function, right, which needs to turn it back into a string. Missing patterns, bam. Add in a conjured string that's basically, this is the reverse of what we did a moment ago. Excellent. Okay, so now we've made our new data structures, we made our new implementation, and we maintained API compatibility the entire time. Awesome. Okay, so to sum up, this is where we sort of ended up with the item module. So we've got end day, which is the thing that transitions like quality from one day to the next. We've got init, which is API compatible with the old way. Give me these three values, a string, an int, and another int. I'll give you back an item. We're not exposing the internals of item. It is opaque to other modules, which means that we get to enforce all of our guarantees inside. We have ways for you to get the name, which is internally actually doing some non-trivial logic. We have ways for you to get the quality, which is very trivial. It's just saying quality.toInt. And we have the EndA function to step between them. Cool. Internally, yeah, we do have some more stuff going on. In fact, we don't even have a cell-in internally. That's part of the rule. We don't store quality as an int. We actually store it as a separate type, but nobody outside this module needs to know or care about that. We've maintained backwards compatibility. And yeah, we have this really helpful rule type that's setting us up for success over the long term. Anytime we need to add a new edge case, we add it right there, and then we get missing patterns errors everywhere else that we need to make new changes to this. So unlike before, where we were like, oh man, like, how are we going to deal with all these conditionals and all these things? Like, actually, the conditionals got crushed down really, really low after we worked with these new types. So, going back to the original question, like, with all these types, when should I write tests? It's like, yeah, we still do need tests for the logic. Like, even something as simple as that quality module that's just dealing with, I want this thing to be bounded between 0 and 50, yeah, I'd write a test for that. And especially when it comes to conditionals, like the more branching we have going on, man, like the less help the compiler is going to be and the more helpful tests are going to be. With our regression tests, we talked about like, hey, this is where we're going to start. We're going to verify all of these things are currently true against the public API so that once we're done changing the internals around, we can run them again and they'll still pass, they'll still compile and be able to tell us like, yeah, we actually still did manage to maintain these. Now we know that like, okay, all the tests we did before that were to make sure quality is between 0 and 50, probably not necessary anymore, but hey, we still got them. These 2 fuzz tests, pulling a lot of weight, but like 2 fuzz tests plus 1 opaque type really gives us a lot of strong guarantees. Great example of like types and tests, I think, working together to make us really confident in our code. Finally, the basic pieces of advice, like make data structures in the life of a file. I think all those things still apply. These are just like the sort of bread and butter like ways that I recommend starting with a new module. And really, that's the same technique that we used here to build up this API. Life of a file, types and tests hand in hand, putting these things together, I think it's a great way to write code. Thanks very much.